In this video, I'm going to show you the exact step-by-step process you can use to manage and control costs on construction projects. I'll cover all the core costs and go through detailed worked examples so you can see exactly how to apply it in practice. The core concepts we're going to be covering include budgets and forecasts, contracts, variations and change orders, payments and cash flow, and then look at some different ways you can present this on dashboards to visualize it, and finally, the key interfaces with other project management domains like risk and the schedule. So before we get any further, there's actually 3 foundational concepts you have to have at the front of your mind when you're going through construction cost control. Number 1, an estimate is not a budget. An estimate is simply a prediction of how much we think it will cost to build something, and the entire structure of how one is built is around predicting cost. A budget fundamentally has a different use, which is about managing and tracking cost. A budget needs to be structured around how we're going to be spending money. Number 2, as we proceed through the project, both uncertainty, so risk, will decrease, but also our ability to shape and control the outcomes. Every estimate we do involves uncertainty. It's obviously implied by the name. As you progress through the project, you sign contracts, you lock in contractors, work gets completed, and your uncertainty around the true cost of the work is decreasing. But at the same time, your ability to shape and control the outcomes of the project is also decreasing. You sign contracts with subcontractors. By and large, the price to do that package of work is fixed. You can control variations and manage change effectively, but the actual value is largely fixed and you can't do that much about it. So this has 2 important implications. Time spent planning and setting up the project has a greater impact on the outcomes than work we do towards the tail end of the job. But we also have to balance this against the uncertainty. There's lots of things we don't know and cannot possibly know at the start of the project, so we always need to be thinking about this uncertainty and risk and how we manage it throughout the project. And number 3, which I think is an overlooked part of construction cost control, the cost means nothing if you don't understand scope. You can be amazing at earned value management, spreadsheets, the most fancy Monte Carlo analysis, and sophisticated cost control measures, but if you fundamentally don't understand the substance of the construction work, you cannot control costs. A number on a spreadsheet fundamentally means nothing without understanding the physical construction works that it relates to. If you haven't clearly defined and understood who's responsible for asbestos removal and inclement weather, the $600,000 budget or contract you sign for civil works just doesn't mean that much. So every dollar in your budget is attached to physical construction works, and you always have to keep this relationship at the front of your mind. If you don't fundamentally understand what's driving these costs, you cannot possibly manage them effectively. As we go through the core concepts of construction cost control, I want you to keep a couple of things front of mind. Number 1, your estimate is not your budget. It's the starting point, but a budget is fundamentally a different tool to an estimate. The second one is the more effort you put into planning and setting up things correctly at the start of the project, the more control you have over the outcomes. But we always have to balance this up and keep in the front of our minds what we don't know and where the uncertainty exists in our plan. And finally, every dollar in our budget, every cost we incur, every contract we sign relates to physical construction work, and we need to understand the fundamental activities that are driving costs. At its simplest, construction cost control is about making sure we spend less than what we plan to. So that is the obvious benefit of cost control. We spend less than we planned and our projects generate a profit, but it actually goes much further than this. Good cost control allows us to know and forecast our profitability at any single point in time during a project. This means we can make investment decisions before the end of the project. If we know we're going to generate a healthy profit, potentially we'll have budget to hire an extra project manager or business development manager in the new year. Importantly, it allows us to catch problems early and draw our attention to the things that matter so we can fix things before they become massive issues. It allows us to effectively manage our cash flow so we're not caught needing to borrow money or getting last-minute loans and incurring high lending costs. It supports decisions around scope changes and value engineering. When we understand the true cost of the works, we can make better informed decisions about issues around scope. And finally, it helps us to actually build trust and keep our stakeholders happy because they see what is actually happening. They have accurate predictions of what will happen at the end of the job. And finally, I've found nothing drives accountability in your team like budgets. If your team members have budgets they're working to, they'll fundamentally make decisions that benefit the project overall budget. They'll start carefully paying attention to what they're spending. Okay, so the rest of this video, I'm going to spend going through the 4 fundamental pillars of construction cost control and really diving deep into each of them with worked examples. And fundamentally, every tool or process we use will relate to one of these pillars. So number 1 is the budget. The budget is your baseline for how you plan to spend and then track that expenditure throughout the project. Everything is going to be measured against your budget. Next up, we have commitments and contracts. This is where we procure work from external vendors. We sign agreements with defined scope and price. This is where our budget gets turned into a financial commitment. Then we have forecasting, looking at how much work's being completed, how much we've got left to go, what our current commitments are, what our unallocated budget is, and making predictions on how much we're going to spend to finish the project. And then finally, we have cash flow. So cash flow is all about tracking when money comes in and when money goes out. As we go through the rest of the video, I'm also going to be demoing those concepts in a software called Mastt. And yes, this video is about promoting the software. The team have put a lot of time and effort into building these workflows into the software, but everything we go through, all the concept we explain are broadly applicable. You can do similar things in Excel, Power BI, or whatever tool you choose to use. Mastt just makes them easy and is tailored towards construction. So as we go through this video, we're going to be doing a worked example. Again, examples just make driving all these concepts home so much more practical and real. If you just talk about theory, I get bored talking about theory. It's much better to talk about something in practice so you can see the actual applications of it. So the example project we're going to be doing is the design and construct of a new sports facility. We're going to take on the perspective of head contractor managing subcontractors. Now, the same principles I'm going to talk about cost control will apply whether you're like a project management consultancy, whether you're a client or owner or client rep. So the principles are all the same, but it's going to be managing a big construction project delivered through contractors. It is a suburban greenfield project. It's a single-story community sports facility. It's about 2,800 square meters. And we've got multiple different trades and scopes. So we've got a purpose indoor court, we've got a gym and a fitness area, change rooms, reception, small cafe, and associated car park. It's not too technical about commercial construction. It's more just about the general workforce. So if you do renewable energy projects, if you do industrial projects, if you're managing costs predominantly through subcontracted work, the workflow is going to be very applicable and relevant. Okay, so number 1, construction cost control, and I've already mentioned this twice so far through the video. Your estimate is not a budget. The reason I keep stressing this point is because it is probably the most common mistake I see. The way we build and use an estimate, the fundamental purpose behind it is to calculate how much cost it is going to be to build something. So take this project, for example. If you are the project owner, you probably engaged a quantity surveyor or an estimating firm to come up with an indicative cost to do the project. The entire way they would have structured the cost to do this will be around the easiest way to prepare, justify, and explain the estimate. So they might have used parametric estimating. They might have looked at the total square meters and inferred a cost from that. Or depending on the level of detail, they might have actually done a more detailed price and broken it down into subcontractor trades and got quotes from the market. But really depends on how they've structured the estimate and how they've broken down the costs. When we set up a budget, we have to answer the question, who are we paying and how much? Which again might be completely different to how the estimate is structured. So this is the structure you should think about your budget. Now, I'm using the example from the perspective of a head contractor, so I'm looking at incoming costs as revenue, but if you're the client, the project owner, that just replace that with your budget or your approved budget to do the project. Now, obviously, if you are the project owner, you won't have a margin on your costs, you'll just have a cost baseline. But when we get the cost baseline, so our costs, our bucket of money we have to complete the project, there's really 2 first categories I would break this down into. We've got our direct and indirect costs. So these are the costs to do the physical construction work. and we have our risk and opportunity. So risk and opportunity is our allowance for uncertainty and change throughout the course of the project. So we take our risk and opportunity, we move it into our contingency buckets. We could break down contingency into separate buckets, but we take that aside. Then we have our direct and indirect costs, which we turn into cost codes. Cost codes are a fancy way of saying buckets, sub-buckets of money or accounts to pay for certain items of scope. So we might have a cost code for concrete, earthworks, electrical, fit out, all these different trades that go into the building. Then from our cost codes, we have our commitments. So a commitment is, say we have a bucket of money of $1 million to do the concreting work. We then do our procurement. We get 3 quotes from the market. We sign a contract for $950,000 to do the concrete work. That commitment is our procured scope, which hopefully is less than the cost code budget. If it's more, we would have a buying loss. If it's less, we have a buying gain. So our costs on a project, we can break down into these 2 separate buckets, our direct cost and our indirect cost. So they together make our total cost. If we're talking about a self-performing contracting business, our direct costs, for example, the concrete, would be made up of labor, plant, and materials. We need people to place the concrete. We need the concrete and steel reinforcement. We need a concrete pump to place it. Now, most of our head contractors and project owners, we don't self-perform works. We engage contractors to do it for us. So our predominant direct cost is going to be our subcontract costs. We might have some major free issue materials that we engage, but predominantly the 2 buckets of money we will be talking about is material costs and subcontract costs. Then we have our indirect costs. So our indirect costs are our job running and management costs. You could also refer them to as overheads or preliminaries. Terminology doesn't really matter, but there are 2 predominant buckets of money. We've got our recurring costs and our non-recurring costs. Our recurring costs are things like our project management salaries, hiring office facilities, insurances. These costs accrue depending on how long the project goes for. So that's why in the introduction, when I was saying schedule is an important element of cost control, is the duration of a project impacts the cost of the project. Do we need a project manager for 6 months, 9 months, or 12 months? Then we've got our non-recurring overhead costs. So these are costs like site establishment, mobilization, one-off expenses. For example, if we have $375,000 for preliminaries in our budget, some of that might be recurring time-driven costs. Other might be site establishment costs that we incur at the start of the job. I would typically break your budget down to cover these costs separately because it's going to help with cash flow forecasting. In my example, I have 11 subcontract packages, including 2 overhead packages. So I have a preliminaries package and I have a free issue package. So our subcontract packages for building works would be something like site works and civil, structures, building envelope, mechanical services, electrical services, all the different trades to do the project. I have a budget per each one. Now, there's our direct costs, our indirect costs. We also have uncertainty built into our price. So this is where I have our contingency buckets of money. So you could have general contingency, which is for unknown unknowns, which isn't allocated to a specific scope, or you could have contingency for specific scope items. For example, design contingency, design growth, or construction contingency, for example, inclement weather or other issues relating to construction. So it really depends whether you can break down contingency or you can just have a central bucket of money. Okay, so we've got our buckets of money, then we have our commitment. So that's within a bucket of money, we're committing to a contractor, signing a contract with them to do a section of the scope. A commitment has 2 dimensions to it. So this is where in the introduction where I spoke about how important scope is as a part of cost control, commitments really have 2 dimensions. There is the price we're paying for the service provided by the contractor. So a concreting contractor is charging us $82,000. Then there is the scope and terms and conditions that surround that scope. Price and terms are fundamentally related. We change the scope, we change the price. We change the duration of the project, it'll impact the price the contractor is charging us. So if we don't understand the scope they're actually doing, what are the inclusions and exclusions, what information it's based on, we don't understand the price, and therefore we don't understand the cost of the project. So yes, this will get entered into our budget as a contract sum of $395,000. But again, this is a super brief example, but these pages of contract terms and conditions, the drawings they base the contract on, that is truly what is driving the price. So I don't want to make this a video about procurement, so I'm just going to touch on it. But procurement, an effective procurement manager, is probably the single biggest driver you have to control the cost of the project. And fundamentally, procurement is just the process of how you find a contractor to do the work for you. And the procurement process is how you go about agreeing on price and terms with them. But long story short, you're trying to optimize for value for money. You're trying to find the best possible contractor at the lowest possible cost. And the underlying driver behind this is going to be clearly defined scope, terms and conditions that fundamentally is going to lead to less variations during construction. And again, as I said, it's impossible to control all uncertainty, but you can control a lot of it by careful planning and thinking through the actual logistics of how the project is going to be delivered. Okay, so if I go to my cost control tool, I go to the contracts tab, I can see all the contracts that I have signed with vendors. Each of these contracts is represented as a schedule of values or payment certificate or however you call it. But it's basically a breakdown of the scope into quantities and rates. So if I look at my electrical commitments or my electrical contract, the contractor is going to charge us 288 grand to do the work. That makes up 42 grand for the switchboards, 38 grand for the central power outlets, the lighting, data and communication, all this stuff. And basically, this is the total value we're going to pay them to do the work, assuming nothing changes. And the document that defines this is the subcontract scope of works. Now, a cool feature with Mastt is they basically allow you to easily import contracts with contracts variations, all these sorts of documents with AI and extract all the line items. All right, so going back to our cost control process, we have so far broken the project down into cost codes or control accounts, and then we have got our procured scope. The difference between the total value of our cost codes and the total value of our procured scope are our buying gains or losses. Now, there are different approaches to how you could deal with buying gains or losses, but the fundamental thing to understand is your budget for a subcontract or contracted package of works should be the contract sum plus any forecast variations. So I'm going to talk about forecasting in a little bit more detail in a second, but fundamentally, you should have budget in your subcontract codes for known or very likely variations. But any other buying gains you get, you should exclude those from your actual budgets and hold those as put those in general contingency. If you have the opposite, if you have buying losses where, for example, your contract value, for example, with our structures package, the contract value or what our subcontractor quoted us was 615 grand, but our original budget was 580 grand. We should adjust our budget to basically move money out of general contingency and transfer it into that cost code. So I guess what I'm saying in a roundabout way is there's really two stages to the budget formation. You form your original budget based on your estimate, you go to market, you get quotes, you're buying gains or losses, you'll have to do some transfers between funds and you'll have to do some forecasting of likely variations. But that forecasting of likely variations against each of the package is going to fundamentally relate to what is in and out of the contractor's scope of works, what they have excluded for their offer, all these sorts of things. So again, you really need to understand the underlying scope of the contract. So our budget is set. We've done our procurement, made our contracts. We've reallocated budget to where we're over and under cost. Next thing we have to do is deliver the project. As we all know, when we execute a construction project, things change. Things will undoubtedly, certainly change. There's stuff we haven't thought about. There's unknown situations that come up. The client instigates change. All these different things happen. Now, as we're predominantly subcontracting out the build, when we have a change in terms to any of our subcontractors, we have a change in price. So, for example, in our electrical contractor's scope of works, we're putting a new fancy solar system on the building. The client actually decides, well, we want to make our solar system 20% bigger. What this means is that we would have an upstream claim to our client. So we would be able to put in a variation for the additional work. And our electrical subcontractor, who've already signed and committed to a cost based on a set solar system design, is going to make a claim for us for the additional work. So variations are going to be both upstream and downstream. We're going to put in variations to our client and then adjust our budgets or our buckets of money we have to do the work and our contractors are going to put in variations to us. So we get this request from the client to increase the size of the solar system. We go to our electrical contractor, we ask them to quote the increase in size. They tell us it's going to be $25,000 more. And because they've already ordered the panels, it's actually going to extend the duration of the project by a couple of weeks. So then we make an upstream claim to our client. We say, well, this is going to extend the finish date out slightly. We're going to have a project manager on site a bit longer. So we have the direct cost to our subcontractor, and we're also going to have to increase our preliminary costs to cover the additional duration. I guess, as you can see, it's hard to talk about costs without talking about contracts because the two concepts are just so fundamentally related. But I don't want to make this a long video about variations and the different types of variations. All you really need to understand, and this is going to relate to how we forecast out variations, is you have proposed variations where the client proposes additional scope. These practically would never be in our forecast unless our client has already told us these are coming up. Because how can we possibly know that the client is going to add 20% to their solar system? And anyway, it would be an upstream claim for us. So we would always get additional budget to do the work. So it doesn't make sense to hold that in our current budget. Now, the likely type of variation that we need to include our budget are claimed variations. This is where we have known scope gaps, known issues that are going to come up that aren't clearly defined in scope. We know our electrical contractor is going to put in additional costs for coordinating with the concreting contractor because they excluded putting in the penetrations. These are things we know are going to come up. The scope gaps and issues that we have come across. These are the types of things we have to forecast and include in our subcontract budget allowances. So these are the things we know are going to come up. The cleanest way to do this is to capture these as forecast variations. So for example, I want to add a variation. I know that, for example, our electrical contractor, PV system size increase, we're varying the electrical services contract, and this is going to be we could say it's a scope change, but we'll say it's a design error. So for example, it wasn't properly specified on the drawings, the size of the PV system. But it's good to track the categories of variations as well. But the different status of the variations is we can have a forecast variation. Again, money we're allowing in our budget for something we're relatively certain is going to come up. We can have a pending variation where our subcontractor has submitted to us and we're in the process of negotiating it. We can have an in-principle agreement where we've agreed on the cost and the change of scope. We just haven't actually entered it into contract yet. We could have it when it's signed and approved, or we could have rejected and withdrawn. So I think it's very good practice to track every variation as soon as they come up in a register and properly put the status in there. Now, when we're putting in forecast variations, that should be for stuff where 90% plus sure is going to come up eventually. If we have cost items which we're not 100% sure about, we can add in an element of uncertainty to them. So again, our forecast cost per package is going to be our committed cost, what we've signed a contract to do, what we're varying the contract to do, and then forecast allowances. And then our forecast for the total project is going to be a combination of the sum of our cost codes plus our contingency. So our cost code should have this forecast amount in it. The sum of all these will have the individual contingency or unallocated spend per package. Then our total project forecast will be the sum of the contracts with the individual forecasts plus our overall contingency. So forecasting, as the name implies, is fundamentally all about looking forward. And fundamentally what we're trying to do is calculate what is referred to as our FFC, our forecast final cost. This is the number all our management, board of directors, whoever's overseeing the project fundamentally cares about. And then therefore, the gap between our forecast final cost and our budget is the profit or loss of the project. And by forecasting out this number, by knowing our forecast final cost, we can act in a way to change it. Obviously, if we've already spent all the money, we know what our true costs are, we can't do much to fix it. Again, this comes back to that principle I was talking about, is the earlier we can flag when things are going to go wrong, the earlier we can work out where the problems are in our project, the quicker we can do things about it. So a forecast item, again, will relate to the actual scope of the work. You can have an uncommitted forecast, which is just something we think is going to come up. We can have client contingency. Say our client wants us to hold money for something they're planning on proposing in the future, or we can have project contingency. We know there's unknown geotechnical conditions. We assess that as, say, worst case, the ground conditions are worse than we expected, and we need to allow for 2 weeks for a subcontract civil crew. The crew is going to cost us $15,000 per week. So our starting amount is $30,000. But again, because it's a forecast, it's a prediction about the future, we have to add this element of uncertainty to it. So I'm going to say ground conditions, 50% likely. Original assumption is 50% likely, needs further investigation. And the budget that is coming from is our site and civil works. I'll add this as an open contingency. And now if I look at my budget for site and civil works, we've got our original budget. We've got the contract value we let, which is $435,000. And then we should have gone through and reallocated budget based on our actual contracts. And then we have this uncommitted cost of $15,000, which is our forecast for potentially unknown ground conditions. So we're forecasting our final cost of $450,000 for that package, which is $435,000 of contract spend plus $15,000 for this unknown ground conditions, gives us a forecast final cost of $450,000 and a big red number of minus $30,000, which is the difference between the original budget we had for the task, which is $420,000, and our forecast final cost. Instantly, anyone can go and look at that number and realize that we're going to have problems. I mean, it's such a simple and straightforward idea, but the fact that we know where the variance is in all of our codes is we instantly know where the problems are we should be paying attention to. Okay, so far we've in principally only spoken about project profit and loss. We've been looking at, is the project going to make money? Is it going to lose money? Our contract commitments, forecasting out our spend. But what we haven't been paying attention to is when all this money is coming in and out. And as the saying goes in construction, cash is king. Lots of contractors have run into serious problems on profitable jobs because they're incurring their costs way before they're billing their clients for the work. This can lead to all sorts of problems like having to borrow money from the bank, incur high interest rates, or even potentially going bankrupt because you can't pay your bills even though you know you will eventually have money coming in. So understanding when we're actually paying our bills is absolutely essential, and tracking our costs incurred. So the fundamental vehicle through which we're going to pay our bills is going to be through progress claims from subcontractors. This is when they're going to bill us for the work they've completed. So for example, our fire protection subcontract had an initial contract value of $188,000. They haven't put in any variations, but they've started work on site. They've claimed, say, 20% for the design work, 30% for the procurement of the fire hose reels, and 40% because they've actually started on site doing fire penetration sealing. So they've put in a progress claim for 18.81%, which is just the aggregate sum of all these items, or $22,200. We approved it on the 21st of February. So they put in a payment claim for the work. So this is now paid. So it is money that is left our bank account. So as the work proceeds, obviously all our contractors are going to start billing us for the work we've done, which means we need to start looking at the overall cash flow of the project. So any cash flow forecast is fundamentally looking at basically how much we're going to be spending each month. We can layer onto this when we're actually billing the client for work and the payment claims, but fundamentally it's driven by when we're incurring our bills. So if I look at typical construction budget of $509,000, we can see each month we've been paying $130, some range between this. Then we've got also our forecast payment. So this is going to be a combination of our contract value, so forecasting out the spend of $100,000 on the civil works across 3 months would be, well, I should have done 5 months, $20,000 a month. That'd be forecasting out like that. Then we can also look at when we're likely to incur our uncommitted costs. We put all this information together, we get nice, simple charts that look at our cash flow. So if we're a project management organization, we can tell our financiers, when we need money coming in, or if we're a contractor, we can compare this to when we're billing the client to, again, try and make this as cash flow as positive. Most construction projects follow what is referred to as an S-curve pattern. So an S-curve is when at the start of the project, you've only got a little bit of work happening. Maybe you're starting to incur some design costs, fees to council or things like that. So you're spending a little bit of money. Maybe you have some staff starting to work on the project and build their time to it. Then you start to get contractors on site, get more and more people on site, more and more claims from contractors. So it really ramps up in the middle where you're spending a lot of money, and then it tailors off towards the end. So most construction projects follow what is referred to as an S-curve pattern. So the final thing I want to talk about are some different ways that you can visualize your cash position on a project. Because again, everyone loves diagrams over long text explanation. So anything you can capture in a simple visual is going to be much more useful. So the absolute simplest one and probably the best one is a simple budget versus your forecast final cost. So what it shows is a waterfall diagram where you can show your original budget, so $4,050,000, your variance to the budget. In this case, this is good because your forecast final cost is coming in under your budget. That would be red if the forecast final cost was over your budget. Then anyone looking at this can instantly see that we're looking at making a gain of 700 grand. Then the final thing you could show is what you've actually spent. The reason what you've spent is important as an indicator like this is you can look at that $197,000. You can say, well, we've only spent a very small portion of the overall project budget. So there is probably a lot of uncertainty in this number. If what you had spent was almost up to the project value, you could say, well, the project's almost finished. There's probably quite a bit of certainty in that number. Then we have our cash flow forecast, like I was talking about just a second ago, but it's basically mapping out what we're spending each month. We can put a cumulative line on it to get that S-curve shape. And then also when we forecast out our final cost, anyone who's financing or checking whether you're going to get enough revenue from your client, you can simply look at the S-curve to work out when you're likely to spend money. You can take that same information in the waterfall chart and put it into a simple table. So this would give a little bit of explanation around these numbers. And if you are doing your unallocated spend or your forecast costs with a bit of uncertainty in it, you can include some sort of upper and lower variance. So including a range in what of these forecast costs you're likely to incur will give you a variance around these numbers. And again, it's just more detail and explanation on top of a simple chart like this. And then a final thing, which is very useful if someone wants more detail into the actual breakdowns, is just taking something like our contracts table or our budgets table and just showing it as a register with all the key bits of information. And then finally, we can show other sorts of health indicators like a breakdown of the different types of variations, what scope is driving them. We could do a breakdown of the overall project value as a pie chart. So again, you can see clearly where the issues are, where the total value is. You could create a traffic light chart looking at all the different budgets and what is most over and most under. Really, it all comes down to answering this question is what is the core message you want to explain? Or if you are somebody who is having the chart designed for them, what do you actually want to know? But yeah, I want to wrap up by talking about two really important concepts in a bit more detail on how they relate to cost control. So number one is scheduling, time management, whatever you call it, basically how you control the overall duration of the project. The reason this is really important comes down to two things. Number one are your preliminary costs. So if you're paying for project manager, an engineer, a supervisor, all these different overhead roles, you're hiring office facilities, the duration of the project impacts the cost of your preliminaries. So any preliminary budget you have, the unit of measure for that is going to be the duration of the project. You might be paying overheads of $10,000, $20,000, $50,000 a week, and therefore the number of weeks left to finish the job is absolutely essential to understand. Now, this doesn't need to be any insanely complicated 2,000 line P6 schedule where you have 100 different activity dependencies for every task and you have all these tasks with different varying degrees of float, and it takes 4 weeks to make any minor schedule update. Something really simple like an overall Gantt chart with the key stages of the project mapped into the key phases with indicative durations and what your original budget was built on. Say it was a 12-month project, just mapping these out. Then once a week, tracking how these are all progressing. Because if you can forecast out the duration of the project, you can much more accurately forecast your preliminary costs. Now, the other way this matters is your subcontractors also incur costs based on duration and staging of the project. So sequencing subcontractors, what date you're telling them to come to site, what sort of access they have to do the work. It all comes down to properly understanding and sequencing the work. So managing the schedule effectively, obviously, it helps you manage your indirect costs and overhead costs, but it actually helps you to more efficiently manage your direct costs. Because fundamentally, if you know exactly when everything's happening and you can tell to your subcontractor, you can come to site on this exact date, you'll have clear access to do the work. They can come in, get the work done. They're obviously going to save money. They're not going to be looking for variations or claims from you. So it's going to help a lot managing your direct costs. Now, I've obviously spoken about this a lot, but yes, construction projects do involve a lot of uncertainty, and how you choose to manage this uncertainty is absolutely essential. So risk is just broadly the concept in construction project management of how you deal with the uncertainty that matters to the project. What do you not know and why does it matter? So really having some sort of process around which you identify where the uncertainty is and what you can do about it, and understand this concept of a treatment. So treatment is basically anything we do to basically reduce either the likelihood of a risk occurring or the impact if it does occur. So long story short, both your ability to manage the end project or the cost and actually understand what that is likely to be is going to be drastically improved by your ability to manage risk. So long story short, construction cost control is all about how you track, manage, and control costs so you spend less money than what you planned. If you are interested in a more in-depth guide on contracts or procurement and how to manage it, then definitely comment down below and we can prepare something if there's enough interest.